In this section, you will describe patterns and use inductive reasonings. A conjecture, and that's the new vocab word, a conjecture is based on observations. And observations can describe a visual pattern, a number pattern, or other observations. So let's take an example of a visual pattern. That's a square. I've divided the square into half. I've divided the square into fours, and I could continue to divide the square so that it's half of before, 1/4 of before, 1/8 of before, etc., etc. That is called a visual pattern. Now let's compare it to a number pattern. A number pattern could be something like this. We start with the number, well, let's start with 20. And then 10, and then 5. So what's the next number going to be? The pattern I observe is that I am dividing the first number here by half to get the number 10. So you're really multiplying by 1/2, and over here as well you are multiplying by next half. So based on this observation, my next number will be 2.5. Now this is a prediction, it's a conjecture based on this number pattern. What do we mean by other observations? Let's say we see school, and every morning we see a lot of cars in the morning at 8:30. So we could make a conjecture that this school starts at 8:30. We have no way to prove this, but it's a reasonable conjecture. So when we use a conjecture, the kind of reasoning that we use is called inductive reasoning. Well, anyway, use inductive reasoning. You use inductive reasoning when you see a pattern based on a few observations, and then you make a prediction or conjecture for the general case. Okay, as I said before, here is an example that is based on observations. So you see cars parked outside the school at 3:30 for a whole school week. What conjecture can you make based on these 5 observations? The conjecture I would make is school closes at 3:30 p.m. Monday to Friday. To show that a conjecture is true, you need to show that it is true for all cases. And to show that the conjecture is false, you need to show that it is false for only one case. Okay, so let's look at this. Next example. You state that the product of 2 negative fractions is always less than 0. Okay, Miss Irma Contrary always tries to prove your conjecture wrong. How can she show that your conjecture is false? Use an example. Alright, so the example that I would use, and I'm thinking out aloud, so you state the product of two negative fractions. So let me pick two negative fractions first. I am going to pick negative half, and I am going to pick negative 1/4. And if I multiply those, I will get, well, based on this, it would say that Miss Irma Contrary is wrong and I am right. But you know, Miss Irma Contrary is quite devious. So then she chooses another example, and the example she chooses is negative 7/8 times negative 6/5. Note, these are both fractions, and the result is 42/40. This is obviously greater than 1, and therefore it's greater than 0. So now Miss Irma Contrary has proven you wrong. So what we are learning is that to prove a conjecture false, you only need one counterexample.